The theme of my presentation is bringing space sciences to the classroom. So the big part of the presentation is presenting several projects related to space science. And in the middle of doing this, I related that part with the lifelong teacher training. This is like when you look to these logos, this was what I worked this year, and this is a year reflection about my work as a teacher. Here I have my summary. You can see theoretical background, problem and goals, learning activities, lifelong teacher training, and then the projects, workshop astronomy on my mobile phone, the major project, Our Space, Our Future, Scratch Machine Learning, AstroPy, Mission Zero, Climate Detective Zero Browser, and in the end, Sloan Digital Sky Survey. And then the conclusion and the references. So the importance of going to where the students are, not only in terms of interest and values, but also physically, is very high. Context masters and opportunities of wider venues other than schools, such as working with community, should be considered. This is accessible, safe, supportive, familiar, and enable wider interactions with peers and familiar community members. Non-school settings to explore science for teachers, such as science centers, are also venues that are rich with opportunity for educational framed real-world phenomena. Online engagements providing two-way communication with students through websites and social media can also be a powerful strategy for a wider geographic demographic reach. The teachers are integral to the success of any intervention in school, particularly in terms of the legacy of approaches such as supporting science capital, supporting cross-curriculum teaching of space, the teaching of science and careers, or the implementation and prolonged engagement with practical researchers that promote high-order thinking and real science approach. The importance of the teacher's role and how school science is implemented contributes immensely to students' attitudes and perceptions of science. Encouraging the feeling of belonging and confidence with science is also captured by space science projects, and literature supports the widening perception of science, providing transferable skills. The problem I tried to solving this work was, what is the relation between the type and duration of lifelong teacher training and the time and quality that takes to the teacher bring space science activities to the classroom. I have some goals to list and classify the type of lifelong teacher training that contributes to application of the class activities, describe classroom activities accomplished along the school year accordingly with the teacher training institution, to give examples of classroom activities for each project developed, to reflect about influence of the activities on the motivation and learning of students, and to reflect about the influence of the duration of lifelong teacher training on the implementation of the class activities. The curriculum framework, there were two subjects, natural science and physics and chemistry. They work together in some of the projects. In curriculum contents, we have space, Earth in transformation, and Earth sustainability. We wanted that students developed investigative skill areas, ICT, reasoning and problem solving, critical and creative thinking, interpersonal relationship, personal development and autonomy, scientific and technological knowledge. In this project, especially in the big one, that I told you about, all the classes, 14 of 7th grade participated with 326 students and eight teachers of science and all other teachers also came in to the projects when was necessary. And my school is near Lisbon. The lifelong teacher training in Portugal is divided in three types: short duration formations, 3 to 6 hours, formation actions, 12 to 25 hours, training workshops, 50 hours or more. This is a graph of my number of hours of formation related to space, and as you see, I was not a teacher that was very interested in space in the past, but as time came along, I'm becoming a fan of space. Here is all the formations, the type of formations, and if the teacher trainers or the scientists go to the school, to the classroom or not. So what is the first conclusions? Núclio, if we look at the formations, it prefers longer formations, and they go to the classrooms. Zero, for example, prefers shorter formations, and the other ones don't have enough to come to a conclusion.